going to go ahead and finish up section 6.2 to begin with today. And we're going to talk about the definitions of less than and greater than. And you've been working some problems that have these symbols in them, of course, already in this section. But to talk about A over B being less than C over D, this will happen if the C over D minus the A over B is positive. And I'll use whole numbers here for just a moment because it works the same way whether I use fractions or whole numbers. All this is saying is that, for instance, if 5 is less than 7, then what it means is that if I take the 7 minus the 5, I will get a positive number when I do that. Whichever one's larger, if I take that larger value minus a smaller value, I end up with a value that is positive. And likewise, we could talk about the values being larger or greater than if I take, I don't know, we'll take 10 and we'll say that 10 is greater than 5. If, again, I take the larger value, the C over D, or I'm sorry, this one's talking about something different, I apologize. This is saying that the 10 over 5 is greater than 5. 10 is greater than 5 is a similar statement to saying if 5 is less than 10. So we can switch the inequality around. That's all it's saying. And again, I used whole numbers, but fractions work the same way. There's nothing different about that process. Estimation is the last thing in this section that we haven't actually covered. On estimation, what we're actually looking at is we're looking at fractions often anyway that are easier to work with. Maybe they're easier to work with because they're familiar to us, or maybe they're easier to work with because they have a 1 in the numerator. There can be a lot of reasons why a fraction is easier to work with than something else. These are some examples that are easier to work with kinds of fractions. Now, in your book, some of the times they'll ask you to estimate, and they'll give you some examples, like they'll give you, I'm trying to think, there's one problem that says to decide which of the following numbers is the closest estimate. And it'll give you, like, it's like multiple choice. Let me say it that way. Basically, they say, which one of these 4 is the closest to the value you're given? Now, the one that we're going to do on the board here doesn't actually say that. It just says to estimate it and decide if your value that you've estimated to is higher or lower than the actual value. So we're going to take this number that's 12 over 82, and we're going to change the 12, change the 82, change the 12 over 82 into a fraction that's a little bit easier for us to think about or work with than 12 over 82. So any ideas about what we might use?
12 over 84.
You could do 12 over 84. Why would you like 12 over 84? Okay, so if you take 12 over 84, you're recognizing that 84 has a factor of 12 in it. Is that right? And so you're saying that this would, I shouldn't have put equals. Let me change that. So this is approximately equal to this. And we would get, this actually equals then 1 over 7 is what you're suggesting, right? Did anyone think of another option? That works great. There's nothing wrong with that. There's other options that we could do too.
10 over 80.
You could also estimate it to be 10 over 80. And then you'd get the estimation of 1/8. 1/8 and 1/7 is pretty close together. So they're both good estimates for this. And depending on what we're using after that, we could decide if we ended up getting something that was bigger or smaller than we were before. Now, if we do the 1/7, it's actually really easy to decide if the fraction is bigger or smaller than it was before. Because if you take a look at 1 over 7 and you compare it back to the 12 over 82, all I did to change 12 over 82 into 1 over 7, or all that you suggested that I do, was to change the denominator. Well, when you make a denominator bigger, do you know what happens to the whole fraction? It gets smaller. So this is actually smaller, or it's a low estimate because it's smaller than it was before. When you change the 10 and the 80 to both of, or the 12 and the 82, both of them, it's a little more difficult to decide whether it's smaller or larger than it was before. You can't just look at it and say, hey, I made the denominator this way, because the problem is on this one, if I take the 12 and turn it into a 10, that would make the fraction smaller. I mean, I made the numerator smaller, it makes the whole thing smaller. But turning the 82 into an 80 should make the fraction bigger. Right? So one place I made it do something that would make it smaller, and the other spot I made it do something that would do it a little bit bigger. So I'm not going to be too concerned with how you decide if it's high or low estimate. If you'd like to take a look at their decimal approximations and make that decision, that's okay with me. This is actually a low estimate as well for this value. Okay, and again, one way you could do that is you could look at the decimal approximations and compare them on your calculator. How about 2 over 1001? This one has a really nice way of making it simpler. Any thoughts?
2 over 1,000.
Yeah, I like putting it as 2 over 1,000 too. 1,000 as well. What is 2 over 1,000 going to equal to? 1 over 500. So this would be an estimate. It's at least easier to think about than the first one, right? 1,001 as a denominator, I mean, really? It's almost 1,000, agreed? But when I changed the 1,001 to the number 1,000, did I make the denominator bigger or smaller? Smaller. The denominator is smaller, right? 1,001 turns into 1,000. If the denominator is smaller, then the fraction is bigger. This estimate is a high estimate. And again, if you don't like my reasoning of smaller denominator, bigger fraction, and so forth, you're welcome to take a look at the decimal approximation and take a look at it from that perspective.
I have a question.
Yeah.
I'm a little out of it today, but on the other one,
Mm-hmm.
you turned the 12 over, you made the 82 into 84, but it's still a low estimate. But on this one, or,
The 12 over 84, is that what you're looking at? Here?
I guess I'm just trying to figure out how we know it's low or high for sure.
Well, if I look at the 1/7 example here, the reason that this one became a low estimate is because I made the denominator bigger.
Okay.
So that the 84 is bigger, and if you divide by a bigger number, fractions get smaller.
And then on the bottom one, it's still low.
And then over here, I actually ended up dividing or getting the denominator smaller. Hang on. Yeah, smaller. And so the fraction gets bigger. The problem with this one is that you can't just look at the top or the bottom. Because if you just look at the bottom, 82 to 80, it should be getting bigger. Agreed?
Yeah, that's what I was kind of.
But I also changed the 12 to a 10.
Okay.
And I made 2 changes. And since I made 2 changes that don't do the same thing, one of them made the fraction bigger, the denominator. The numerator change made the fraction smaller,
Okay.
12 changing into 10. And actually, the reason that this still ends up being a low estimate, that is the 12 turning into 10 being the low part of it, is because 12 and 10 is a bigger change than 80 to 82.
Okay.
That's why. Comparatively, it's a bigger change because the numbers were smaller to start with than the other one. So that's where you're ending up.
Okay.
All right. Any other questions on this one? We have one more problem to take a look at. Okay. Periodically throughout the semester, you're going to be given opportunities to work out a problem where you get to write the problem. Oh, I see people shaking their heads. There's an opportunity. The reality is that if you're teaching, at some point you're going to have some students going to make you have to create a problem on the spot. And so it's a good practice to get into, and you may not create the best problem on the spot. I don't always myself. But being able to just create a problem is a good skill to have. So this is an example of a way to do that. Now, this problem doesn't actually ask you to solve the problem. It just asks you to create it, which means it should be easier than asking you to solve it. Now, a lot of times when I ask you to do something like to create a problem on a test, I'll give a lot of instructions. Some of the things that I like you to think about is, first of all, is the problem applicable to a young child, right? So I had one semester where people were giving me lots of examples of Starbucks coffee, which is great. They were doing it in their presentation, so that was fine. But Starbucks coffee is probably not a good example for a 4th grader. I mean, right? They don't drink Starbucks coffee. Okay? So you want to think about when you're creating problems something that's going to be applicable to young children. Okay? Also, that actually works with the context you're given. So, for instance, the 5 1/4 and the 2 1/3. I don't want to talk about having 5 1/4 jelly beans. We don't have 5 1/4 jelly beans. It doesn't even make sense, right? The context doesn't work for jelly beans. Now, we could have 5 1/4 bags of jelly beans. Do you see the difference? So you have to think about how you're wording it if it really makes sense, okay? So what I want you to take just 3 minutes to do is I want you to think of a context for the numbers 5 1/4 and 2 1/3 and why you might subtract them, and then create a word problem for a child that would require them to do so. Okay, so some kind of a word problem that requires a child to say to look at read the problem and say, oh yeah, I have to do 5 1/4 minus 2 1/3. Are you guys with me? Okay. It doesn't have to be the world's greatest problem, but just give it your shot. This is the first time I've asked you to do it, and see what you can come up with. Okay, does everybody have something written down, or most of something written down? Okay. Would you care to give me an example? Somebody tell me what you wrote.
I'll do it.
Thank you.
You are given 5 1/4 bags of M&Ms. You and your friends eat 2 1/3 of the bags of M&Ms. How many bags will you have left to share with your brother and sister?
Excellent. Okay, what else? Kids like M&Ms, so that works, right? Yeah. Yes.
Sally has a leftover bag of Cheetos. The bag is 5 1/4 full. She shares 2 1/3 of the bag with friends. How much is left?
Okay, so there's one problem with the way that you've written it. Did anyone catch what the problem is? Yeah, what'd you?
5 holes and 1/4.
Yeah, you have to remember that when you're dealing with the numbers like 5 1/4, it's 5 wholes, so she'd actually have to have like 5 bags of Cheetos and 1/4. And then she'd have to eat 2 bags of Cheetos and 1/3. So you have to remember what the context of the two values are, but it still works. We just need to make that change in order to fix that part of it. Did anyone have something that they weren't eating food?
A boy wanted to walk 5 1/4 miles in a day. He's already walked 2 miles. How much farther does he have?
Excellent. That's very similar to the one that I have written down. It was about walking, so that's good. Yeah, so it doesn't have to be about a product. It could also be about mileage, which would work on this particular one. Yeah. Okay, so you guys get a feel for how that works, right? Excellent.